Okay, hi everyone. Do you guys hear me well?
Yes.
Okay, hi everyone. Do you guys Oh, let me see because I think that I might have some. I don't know if I have some echo. I think this sounds great, right? So thank you everyone for. Is the echo from you guys or from me? So thank you everyone for. Is the echo from you guys or from me? Hello? Yeah, I think somebody might have the live stream open. I don't know, it might be me. Let me 1 second. Yeah, I think somebody might have the live stream open. I don't know. Okay, hi everyone. Sorry about that. That was definitely me. Thank you everyone for joining our mini course on AI within the world of UX. We're really excited to have you here in this course. Thank you very much on one hand to Ria, who is organizing this whole conference around AI for Latin America. Thank you very much to Toloka, who is here with us, and they're going to be providing you with tools so that you can learn how you can improve the user experience through crowdsourcing in your AI. Thank you very much to UNAM, who is helping us to organize this. Also, Tecno Latinas, who has been really amazing in providing all of the infrastructure. And we have her also as mentors. They're here within the chat, and they're going to be helping all of you. So, let us now, we're going to start now to present. So just as a recap, a lot of the things that we're going to have today is going to be in English. However, I speak Spanish. We also have people who are speaking Russian. And so if you have like any questions, any doubts that you suddenly feel confused, feel free to speak up. You can talk in Spanish, and we'll be happy to help you and respond to your questions. So let us now begin. And also thank you very much to Infotech. Infotech is government-owned, government-funded research institutes in Mexico, and they were also able to connect us with a lot of students. And so I know that right now we have a lot of students from Infotech who are listening to us. And so thank you very much for joining, and thank you very much, Infotech, for helping us to reach you. So let us now begin. So I'm going to start sharing my screen, and I'll start our little mini course, and then Toloka will provide you with a hands-on experience on how you can start to code some of the things that I'm going to be talking about. So let me start to share my screen. Do you guys see my screen? Okay, I hope it's viewable. Okay, 1 second. So this is working. Okay, so thank you, everyone. Welcome to the mini course on user experience in the world of AI. These are our amazing collaborators who have been supporting us throughout for this mini course. Thank you all. So today you're going to learn how you can integrate crowdsourcing into your AI systems, and then we're going to teach you how you can integrate these crowds into an AI pipeline, especially within Toloka platform, so that you can improve your AI. So some of the things to consider is that on one hand, artificial intelligence has been enabling futuristic realities where we have voice assistants who can respond to any question that we're asking. We have self-driving cars who can start to understand the world around us and drive us from one place to another. On the other hand, while AI has been displacing some workers from their jobs, AI has also been creating millions of new jobs. A lot of these jobs have to do with having human workers do the tasks that are difficult for the machine to complete. So you might have human workers who are going to be labeling images. By labeling images, the machine learning model will then be able to better understand the world around them. So the machine learning model will be able to understand, oh, this is a sign, this is not a sign, and your self-driving car will be able to better navigate the world. Other types of tasks that human workers are doing involve transcribing audio. They may be transcribing audio to help, for instance, Alexa be able to understand what the end user is saying. They might also be categorizing content so that Facebook's recommendation algorithm doesn't show you hate speech or pedophilia. Now, a lot of research has gone into thinking about ways in which we can improve the pipeline of integrating these workers into the AI so that the AI is able to better understand what is going on. Now, how it works when we say crowdsourcing, it's basically you are providing an incentive to online workers, and the online workers finish a particular task based on the incentive, for instance, money that you provide, and you get your labor. Then you integrate that labor into your machine learning pipeline. Now, where do these crowds exist? There are different platforms in which these crowds are existing. One of them, for instance, is Amazon Mechanical Turk. Another one is Toloka. Today, we will be learning with the Toloka platform how you can integrate these workers into that platform. Different types of roles that exist on these platforms is, on one hand, you have the requester. The requester is the employer, the company or the individual who is putting out the work for the workers to complete. And then you have the workers who are completing the different tasks. Again, by completing these different tasks, you can then improve your AI models. For instance, Alexa will be able to better understand rural accents, maybe because you have workers reading out loud, workers from, for instance, Latin America or rural regions. They might be reading content so that Alexa can better understand what the end user is saying, or they might be transcribing audio. They can also be labeling images. Today, we're going to be doing an exercise on the Toloka platform where you are going to get a chance to improve image labeling that is related to self-driving cars. And so this is my presentation. And again, by the way, I'm actively recruiting PhD students. If you're interested in this type of research, please shoot me an email. So that's my presentation about overall, how does crowdsourcing work? So the biggest thing to consider is that you have a task, you dispatch it to workers complete it, you get that data, and then from that data that you get, that labor that you get from workers, you improve your machine learning models, and it can help you to, for instance, create these futuristic realities overall. So that's my part, and now I'll hand it over to Toloka's team, who will be presenting to you the on-hands experiment. Thank you.
Hi everyone, my name is Dmitry Stalov. Give me a second, I need to share with you my screen. Yeah, here it is. And yes. And can you see my slides?
Yes, I can see them.
Yeah, in the business center I'm located in, currently we have some fire alarm drills. I hope they are over, but something might go wrong and may be loud. However, I'm really happy to see you here in a very unusual conference to me because, well, I was located in St. Petersburg, Russia, and I was often all in the conference all over the US and maybe Europe. And here is my very first experience in something in Spanish. I'm really happy to see you here. And I'm Dmitry, and I'm responsible for driving the Toloka research initiatives all around the world. And today I will tell you in my first part about what Toloka is, how it works, what we do with it, and what's really interesting can be achieved using crowdsourcing. And basically, when Yandex was involved in some data-driven enterprises, when Yandex was involved in various tasks that involve data, you need pretty large amounts of data to train your machine learning models. And examples of these tasks are shown in the screen. Yandex was initially a search engine, the very popular search engine in Europe, and now There are many other applications like machine translation, self-driving cars, advertisements, maps, and whatever. And everything is related to the data. And to make the product successful, you need to serve the customers better. And if the content they consume is related to data, you need to achieve the high quality of this data. And that's how it works. So majority machine learning or ML-based solutions require trained data labeled by humans. And that's maybe one of the core pitfalls of the machine learning. You need data, and everybody is talking about methods, but however, well, you need some high-quality data to train your models on, and nobody wants to think about these data sets. And that's what we want to change, and that's what we want to emphasize, because you need high-quality data at a very large scale. And that's where we believe crowdsourcing is a very sweet spot that allows you to obtain these high-quality data sets. And that's what I mean. Crowdsourcing is actually a specific way to design a business process. You have your huge task, you perform some actions, you perform certain manipulations with this
арендаторы и посетители
data.
бизнес-центров.
Sorry.
Проверка систем противопожарной защиты здания завершена.
If you speak Russian, this person said the fire alarm testing is over. I'm really happy to hear that. And we have a very huge task, and we have a cloud of performers, and we need to do something to get a good result. And in my lecture, in my part, I will tell you a brief overview of how it can be achieved. Initially, when people are trying to do something related to the data, they are using experts. You have some pretty sophisticated task, and to train your model, you need to gather data. And these data are often provided by the expert annotators. You gain a group of experts, maybe linguists, maybe computer vision specialists, maybe other professionals, and they ask them to manually annotate certain data sets, either in the form of spreadsheets or maybe in the form of some bounding boxes. Nevertheless, you ask them experts, trusted people who are expensive, unscalable, but they do provide a very good quality of the results. However, if you need to change the task, you need to retrain them completely, and that's a very big issue. And crowdsourcing, in turn, allows you to do actually the opposite thing. You ask a crowd of performers, people who are not real experts in your task, to do something small, but by composing these small steps, by providing the instructions and the appropriate conditions to perform your tasks, you can achieve a good result that is comparable to the expert annotation in a variety of tasks. I will show you a few examples later. And basically, what we say about that is, in the 20th century, there was a management style of cubicles, of routine tasks, regular work, some hangars. That's a very dystopian picture. And you all must do one single task, and it's a routine indeed. And we believe that crowdsourcing allows you to change it, and to change it in a very positive way by allowing flexibility. You can perform different crowdsourcing tasks on a crowdsourcing platform that allow you to switch between them, to switch context, and to some extent be free in terms of the task you do. You don't need to commit or do this many hours per day because, well, it's a crowdsourcing platform. The tasks are small. You just submit the response, and you just can go away, or you can just continue performing them. And it's super easy to change the task by clicking a few buttons. But crowdsourcing, due to its scalability, has some implications and has some additional requirements imposed to the stakeholders. And there are, besides the performers, two kinds of stakeholders. The first one is the platform. Crowdsourcing is usually happening on some crowdsourcing platform, and this platform needs to efficiently match the performers and the requesters. And this matching is not about assigning tasks. It's all about quality control. It's all about some filters, some skill-based assignment, and so on. So it's a very new and very sophisticated machine that needs a lot of things to know. On the other hand, the requester needs to know how to build the crowdsourcing platform in such a way that they offer optimal results. And that's the core competence we emphasize on. If you are curious about the applications of crowdsourcing, all these applications are real and they are happening every day. And the applications of crowdsourcing, as you can see from this table on the screen, span from the information assessment in a very classical example, the information retrieval evaluation or search quality evaluation, which implies there is some query, there's some document, and people need to provide the relevance score for this document query pair. It's the classical applications that was obtained since 2001, I think. But later, people have invented more ways to apply crowdsourcing, starting from something for subjective opinion gathering, like side-by-side comparisons and something like that. Also, crowdsourcing found its way in computer vision techniques like bounding boxes, image segmentation, which is super useful for self-driving cars and maybe other applications. There are indeed some applications in audio tasks like speech recognition, validation of voice assistant output, and much, much more. Here is a very small sample of what can be achieved using crowdsourcing. And my favorite part about it is the following. You can achieve anything as soon as you can explain what you want. If you can explain what you want to the person who is not an expert in your task and in your field, crowdsourcing can make it. And by building the corresponding pipeline of simple tasks, you can achieve very impressive things that do a very positive impact to the world. And let me show you this example. I really like it. Suppose you want to build a data set. You have a huge amount of cat pictures, and you want to label each picture with one binary label. Is this cat white? And if you look at this example, in the very example you see, you hear, you know that this is the question, and here are the labels we can provide for this picture. And if you look at the picture, you will find that it's not that obvious how to respond to this question, because this cat is a lynx boy and Siamese cat. It's not white, it's not black, it's not, well, it's something like the mix of something. And this is the pitfall of crowdsourcing. You need to understand what you are annotating, and you need to put some effort into making clear what you want to achieve. Okay, if this cat is not white, you need to clarify what is a cat, and maybe is tiger a cat or not, or a lion. You need to explain what white means, because the body of this cat is white, but the face is not. Is it okay or not? You need to come up with a pretty clear instruction what you want to achieve. And if you can't do it, you are almost there. And here are more examples of multi-classifications in which we have some text, we have some labels, and we want to provide the corresponding labels to these texts. It's also one of the most successful and simplest examples of using crowdsourcing. And you might want to get some grades of your labels to obtain the document and query matching. This allows you to record these labels and to use them in maybe evaluating your information retrieval system or machine learning system in general. And this is super useful because you offer simple tasks that can be chosen, solved very simply, and this is very useful. However, sometimes it's not really possible to formulate the exact rules that choose the classes. And this leads you to the idea of pairwise comparisons, which means, okay, I cannot come up with exact instruction how to do this. And my tasks may be subjective. I want to provide the best maybe content possible. Suppose you are creating a recommender system. And to build a great recommender system, you need to know what content is the best. And to do this, you can use crowdsourcing to perform what we call pairwise comparisons or side-by-side tasks. You show only two options, left and right, and you ask a very simple question: what is better? And by processing the results you obtain using crowdsourcing, what is better, here or here? you can evaluate and train a very high-quality recommender system, including the information retrieval system. That's a very classic example, and that's super effective in a variety of domains. Another application of crowdsourcing is audio transcription. We have invested into this quite intensively in the recent months, and we have recently seen a lot of the things here. So audio transcription means that you have an audio file obtained, for example, from your voice assistant or maybe from your call center call, and you want to obtain the exact transcription in English or in Spanish or whatever language is available on the platform to further processing. And crowdsourcing allows you to do this. And there are special techniques that allow you to get very high quality of the results, and it's very impressive to see it. And indeed, self-driving cars are all in the news today. Self-driving cars are often annotated on Toloka, and here is the example of the interface, how it's done. So it's object segmentation. Here's the road, here are the cars, here are some environments, here are the objects that are selected by the performers, and it's all done using crowdsourcing, and Toloka in particular. And another task that is often forgotten is spatial crowdsourcing. In spatial crowdsourcing, you ask the performers to do something in the real world, to come to some location in your city and receive certain payment for doing a photo of the organization, or maybe checking the number against the specified in the task and so on. So it affects the real world, and joining the spatial tasks with the machine learning steps and with regular crowdsourcing tasks with online crowd, you can change the world around you by telling what you want. And from the economical point of view, a crowdsourcing platform is a two-sided market. In the middle of the picture, there's a platform, and on one side there are Tolokers, who are the performers that perform the task there. And here is another side who are the requesters. And here we have a very complex economical relationships between these two parts. You need to provide the corresponding matching between these two sides as the platform. However, these parties also need to agree with each other on the conditions under which the tasks are performed. And this is one of the most interesting parts, how to match them, how to make them friends, how to make it a success. It's very interesting. Indeed, there are many crowdsourcing platforms out there. The Amazon Mechanical Turk, there are Toloka, there are much more. And here is a very brief sample. And all these platforms do the matchmaking between these parties. And they are different in terms of the audience they have, the flexibility of the tools they have, the certain technical details that are more convenient or not. And usually it's up to you and your tasks how to choose the platform. And comparing to the 20th century management style, the crowdsourcing platforms offer you 4 very cool properties. The first one is they are available 24/7. So the whole week and anytime you can just upload your task, and within a very short time after that, you will receive some responses. And it's very cool because I need to data in demand. I need to obtain the annotated data on demand. Suppose I want to do some active learning, or I want to do something else that involves the instant data labeling, and crowdsourcing platform allow you to do this. And since you can formulate the tasks and provide training to your performers, they offer a variety of skilled performers who can do your tasks well. At the same time, since crowdsourcing platforms are online on the internet, you can choose the region that you want to target your tasks to. For example, you want to do some cross-cultural study, and you can do this using crowdsourcing platform that exists in these regions. And indeed, since this crowd is available 24/7, it's possible to build ongoing processes that continuously perform some additional annotation to make your business work better. And every day in Toloka, that's our example, we have millions of Tolokers, people who can perform your tasks. We have covered more than 100 countries, and we speak more than 40 languages, including, I think, Spanish. That's what Toloka offers, and I'm really happy to show the platform and the core idea here. Here are some real-life cases on Toloka. We span from side by side that I mentioned, that what's better, here, this and this. We offer them on Toloka. It's a very common pattern of application, the task convergence. So the tasks are done really quick, in the tens of minutes, and they are quite affordable. And also it applies to the other applications like object segmentation, sentiment analysis, etc., etc. And all these things are performed quite quickly. However, we can tell more about how to perform data collection using crowdsourcing efficiently. And here are some common knowledge that applies to any crowdsourcing task you will be involved in. And I will show you the basics of how to do it. And here are some pillars, some core things that need to be done and need to be taken into account while you are involved in some crowdsourcing task design. The core idea is called decomposition. And decomposition is the art, it's still an art maybe, of how to split your very complex task into pieces that are connected to each other, and together they solve your whole task. For every decomposed task, you need a clear instruction. You need to provide a convenient and reasonable task interface. You need to compose means for quality control and aggregation and some economical incentives. And if everything is set up correctly, your annotation results, your crowdsourcing outcome will be optimal. Let's go over each block. Decomposition. The core idea of decomposition is the following. Suppose you have a huge task that requires some expert. You need to find a very rare person who has a lot of expertise, maybe special training, to do it, to provide the label or to select the object. And the core idea of crowdsourcing is you try to separate the specific steps of solving these tasks into simpler tasks called microtasks. And you offer solving these tasks to the crowdsourcing platform. That's the core idea. And you need to perform the split, and you need to design these pieces. The core idea is performers are not experts in your field, and they need some help to make it correctly. And that's the core idea. You need some training, you need some simple tasks to bridge the gap between these two complexities. And I believe that by decomposition, you can offer the performers the way to solve your task without taking into account many other moving parts that can affect the quality. That's the core idea. If you can come up with decomposition, you will be successful. Another thing is instruction. And suppose you have visited a crowdsourcing platform. There are a variety of tasks that need to be done. You choose some. And the only thing you see right now is the task interface. And there might be some pitfalls, maybe some corner cases, what to do. And the only thing that can help you immediately is the instruction. And instruction is super important when it comes to the annotation. So instruction should carefully explain what's the goal, why do we need this. It should provide examples of the interface. It's not obvious sometimes. It is required to have explanations. What are the good labels? What are the bait labels? What are the corner cases? And it might include some references to make sure that those who are interested in them obtain them. And indeed, since your tasks are often not that trivial, you need to cover rare cases. So you need to understand your task really well. The task interface. The best practices are you can use hotkeys, you can use some minimalism to provide the positioning and to provide something like effective navigation to streamline the process. So the performer needs to get into flow, and this feeling of flow will allow them to do this quickly. That's super important. And indeed, you can obtain better quality if you tailor the very specifics for your task. In particular, there are some dynamic interfaces that hide something that are not related to the particular case the performer examines, and so on. So that's super important, and I believe task interface, on the one hand, is a very simple thing to do. On the other hand, this is the front end. This is the face of your task, and you want to make it clear, convenient, and quick. Quality control is one of the most important things of crowdsourcing. Suppose you have decomposed your task correctly. Suppose you have provide a clear instruction and a very cool user interface. Now, here we have quality control. And we consider 3 kinds of quality control techniques. First one are before task performance. You need to perform a careful selection of those who will make your task, those who will submit the labels, because if they cannot solve your task well, it's okay, because, well, people are different, expertise is different, and you don't have this one-size-fits-all solution. So there are specialists in anything. And that's what we call quality control before task performance, the selection and instruction decomposition, etc. During the task performance, you want to evaluate the performers are doing your task well by offering some pre-annotated examples as the check-in tasks. You want to make sure that your interface works well and everything's fine with them. You need to maintain some cheating prevention, just to make sure that people who want to get money will not do this by simply clicking the submit button. You need to take care of this. And after the performance, you need to take care for aggregation, the consensus, and the post-acceptance if it's possible. Now, aggregation. This is another block. This is the core idea of crowdsourcing. Suppose you have a picture, and you want to assign one of the 3 classes I showed you: cat, dog, other. We know that the performers are non-experts in our task, and we want to obtain a good label using crowdsourcing. And the core idea of crowdsourcing is called the overlap. And overlap allows you to show the same picture to multiple performers, and each performer provides one response. However, now you have 1 picture and 3 responses. We need to choose the correct one. And this task is called answer aggregation crowdsourcing. Given these noisy labels provided by the non-experts, we want to infer the correct one. And that's called the aggregated label, and the whole task is called answer aggregation. And that's very important because it allows you to handle very complex tasks. It allows you to estimate the skills of the performers, and there is a huge mathematical field that is focused on it. Indeed, the obvious strategy here is called majority vote. So just pick the most frequent label, the mode of this distribution, and it works surprisingly well. But however, you might want to squeeze the more from your data, and there are special methods that allow you to estimate the performer skills, the popularity of the labels, the difficulty of tasks, and so on, just by taking into account into the data that these performers have presented. And one of the final things related to the quality control is incremental relabeling and pricing. Since we have some two-sided markets, we want to offer the optimal pricing policy. And by pricing policy, right now, I mean the amount of money we spend per good label. And we want to focus the crowd effort to those pictures, to those objects that require more attention, and we don't want to pay too much for the obvious examples that can be handled efficiently. And that's the core idea, that's the core thing behind the incremental relabeling part. We try to optimize the number of labels required to obtain the certain confidence in our results. And indeed, Pricing is still quite an open question in crowdsourcing, and I believe it depends on task design. So the complex task requires more money. And the market economy. If similar tasks are paid this amount of money, we might want to pay the same amount of money. That's called the market. And also, indeed, you might want to increase the result quality and to attract more people into your task by paying more. But also, you can pay bonuses to the performers who gave you some insights and gave you some good information. That's super important as well. And my general idea, if you can take anything from my lecture and only one, you can take the following idea. If you have a good decomposition, then you can get a simple instruction. Your user interface will be convenient and clean. Your performers will perform the task with a high confidence, and it will be easy to control quality. The standard aggregation methods will work well, so you won't need to invent anything new. And it will be easy to control optimized pricing. So decomposition is the core thing in crowdsourcing. By good decomposition and overlap, you can do a lot of things to do. Just as a quick introduction, I want to show you the interface of Toloka for requesters. So one of the sides of our two-sided market, and it's pretty self-explanatory. Here's the menu, and here's the help button. Here are in the green the amount of money you have right now, and to the left we have the amount of money that's currently blocked on your account, since you need to, if you already ran the annotation, you need to be sure that you can pay the performers this money. So here's the blocked money until these tasks are done. And here is your account name in Toloka. So basically, that's that simple. And how Toloka works. You have some data, you formulate the task, you offer this task to the performers, and the performers provide you with the results that you can provide, and they can process, you can reuse, you can share, and all the data belong to you. And in Toloka, we have a pretty sophisticated terminology here that I need to tell you right now. We use the TSV files to input data into output data. So you will be working with TSV files, which are text files, column files that are separated by the tab symbol. Very convenient in Python, Excel, whatever. And we have two kinds of entities here. The project, it's basically the task you offer to the participants, to the performers, to the people. And inside the project, you have pools. A pool is an entity that contains these tasks and the tasks that are actually offered. And the pool has the quality control rules, the pool has filters of the audience you want, and the pool has defined quality control methods. So by setting up annotation in Toloka, first you define the project that contains only the interface and brief description, the title, and the rest of the activities involving quality control are done in pools. And you upload the tasks to the pools. And that's pretty much it. Thank you very much for your attention. I will be ready to answer your questions.
Thank you very much, Dimitri, for these great explanations. I'm going to give a quick little overview for people so that they can start to contextualize a little bit about what Dimitri presented. And meanwhile, please start preparing some of the questions that you might have for Dimitri. So overall, I'm going to say this in Spanish so that it might be maybe easier for a lot of the people that are following us. And I see that we have almost 100 people in both Twitch and YouTube. It's great to have you all here. Okay, entonces, ahorita Dimitri lo que les explicó fue cómo funciona el flujo de poder integrar a obreros dentro de la inteligencia artificial para que los obreros mejoren la inteligencia artificial. ¿cómo es que los obreros van a mejorar tu inteligencia artificial? Muchas veces tú necesitas etiquetas, por ejemplo, para tus modelos de inteligencia artificial y para poder tener esas etiquetas de, por ejemplo, no, pues esto es un vaso, esto es un teléfono, para poder tener esas etiquetas necesitas a humanos que te ayuden a etiquetarlo. Entonces, ellos desde Rusia crearon una plataforma que se llama Toloka, en donde tú puedes acceder a trabajadores y estos trabajadores te van a estar ayudando a etiquetar tu contenido y esas etiquetas ya después te las metes a tu modelo de inteligencia artificial y así tu modelo de inteligencia artificial empieza a reconocer el mundo y navegarlo. Y ahorita les dio muchas diferentes técnicas para que ustedes pudieran mejorar el sistema. Vamos ahorita a tomar preguntas y también ya va a empezar a presentar la parte práctica su colaborador. ¿Alguien tiene preguntas? Veo algunas bueno, aquí ahorita en el, ok, tenemos ahí una de Twitch y también ahorita estoy viendo otras que nos están mandando dentro del chat de RIA. Okay, Dimitri, I have so also for the conference of RIA, they have a little chat, and so I'll start sharing some of the questions. Some of them are coming in from Twitch, YouTube, and we also have another. So we have one, for instance, from Emmanuel. He says, which kind of biases can we expect from crowdsourcing data labeling? And we also have one right now from Twitch, which is, what is the most common mistake found in crowdsourcing? I don't know if you want to start responding, Dimitri, about this one from Emmanuel as well.
Let's begin with the first one. Let me show the slides about the people on Toloka. And my primary response will be the following. So if you collect data from crowdsourcing platform, you will always obtain votes from those who are on this platform. So even if you obtain the data from those who are on the platform, you'll just miss everyone outside it. And if you need to target some specific demographics, you need to make sure that you can find them on the platform. And that's what maybe the primary cause of bias. If there are no people that you need on the platform, you will get biased responses. On the other hand, a very important source of bias is the lack of the clear instructions and the lack of the clear explanations what you want to achieve. And on the other side of the platform, there are people, and they need to understand what you want from them, what do you want from them. And by explaining this clearly, by providing them with the guidance, with the training examples, with the corresponding means for making your task correctly, you can reduce this amount of bias. However, you might want to gather subjective opinions. You need to first investigate what kind of people you have there in the very particular population, in the very particular filter you have, and then gather this subjective opinions by using, for example, pairwise comparisons or side-by-side tasks, and that will allow you to achieve the result. I hope I respond to this question. And for the second question is about the pitfall, I think, in crowdsourcing. I believe one of the hardest pitfalls are the two. That's based on my personal experience. We are running a lot of crowdsourcing tasks almost every day. And just our team, the research team. There are probably two things that hurt the most. That's my experience. The quality control means you need to make sure that the performers have enough skill to address your task correctly. If you need some precision, you need to be very careful about what you want from them. And actually, the only thing that can explain them what do you want from them is the instruction. And to some extent, it's also task interface, but they are quite connected. So you need to be very precise to in the instruction and in quality control, the means, the training, and so on, to make sure that your tasks are done correctly and without any unexpected surprises. That's very important. Okay, more questions, please?
Oh, we have one from CIDEC UVM, which is a university in Mexico. And so they're asking, what about the privacy or other issues related to the source of the data? Great question.
It's a good question. It's a big topic, actually. I can say two things. First, it depends on what do you want from the platform. If you want to annotate private data that which are already personal identify information, you need to do something to make sure you don't expose this means, because you show this information to the internet, and you need to make sure that you have hidden something that can be used to identify people. There are special mathematical methods like differential privacy or something like that that can help you in this. But also when it comes to the privacy of the performers, we provide means that you don't, the requesters cannot reach the performers directly. They can only communicate with Zaloka, and it's not possible to expose anything personal without not just consent. It's not designed for this. So privacy must be established in terms of data, and we have also certain ideas how to slice your pictures to remove some parts of documents using decomposition to ensure privacy. So usually it's done like that.
Great, thank you. We actually have a lot of questions. And so the next one is, they're mentioning, so this platforms could be used to tag different types of requirements. For instance, maybe things that could be critical for a machine learning pipeline and could not be critical. What do you recommend for prioritizing what the requirements should be when you're designing your AI and deciding what type of things you should crowdsource? How do you prioritize?
That's a very good question. I really like it. My opinion is the following. Usually you are not running machine learning per se. You usually have some initial data set. And suppose you have already some prototype, and you clearly see that you don't have enough data, or maybe you need to evaluate your system more carefully. And that is probably the point when you need to think about crowdsourcing. To expand the training set, no problem. You can just decompose your task to run the human-in-the-loop pipeline that streams the data to the platform and pulls it back in the real time. With respect to the processing time by the performers. But also it allows you to perform evaluation by gathering human judgments about your pipeline. And it, to some extent, can replace the computational not quality control, computational evaluation metrics like ranking metrics, the information retrieval metrics. You can replace them with the human judgments by gathering what people really think about your responses, the responses of your system, rather than the some formalized criterion that can be non-objective in some cases. So the core idea is you build a quick prototype. You see that the data you currently have from the open data sets or maybe from your expert annotators are not that complete. And that's the point you need to think about crowdsourcing. And also, if you want to provide a careful human evaluation of the output of your machine learning system, your AI system, you also want to think about crowdsourcing as a means for evaluation. In April at the WebConf conference, we have shown the tutorial that showed how to use crowdsourcing to apply to evaluate the recommender system, the e-commerce systems, and information retrieval systems. It's a very simple approach that works extremely well, and we highly recommend it.
Wonderful, thank you. So now we have this question from Jan, which she's asking, so could you provide just us with a quick overview about the advantages of integrating crowdsourcing, of having people do these tasks simultaneously? And she mentioned that, I'm sorry, I'm learning about crowdsourcing, so I really want to understand the advantages.
The advantages are, well, first, you can, in my opinion, the primary advantage here is the possibility of getting the real human response here. For example, if you are building a recommender system, you cannot actually evaluate it online. And crowdsourcing provides you with the way to do it. You can sample your recommendations to the platform, and by building the pipeline that involves pairwise comparisons, by choosing one of the best option out of two, you can see what people actually prefer, what do they like more, and that's super cool. It cannot be done without it. It's a super cool technique. Also, crowdsourcing allows you to do some tasks that are hard for the machines to some extent. There are some tasks that involve, that for which there are not so many data sets. Recently, we have a paper accepted at the new RIPS 2021 datasets and benchmarks track, when we built an audio transcription dataset using crowdsourcing for evaluating the sequence aggregation methods. And by crowdsourcing, we were able to obtain quite a large-scale dataset very quickly without any big issues or mistakes. So crowdsourcing allows you to get the data quick and usually in a decent quality. So that's the primary advantages.
Excellent. Thank you very much, Dimitri. Very, very clear. So we have, maybe we can take the last question. I noticed that Tick Summers, Gatos Ricos, and also Soel Pokichan, they all had similar questions where they were asking about, well, how exactly can we work in crowdsourcing platforms? Which ones do you recommend? And actually, that's going to be related to what we're going to be doing next, which is going to be a very practical example. And Gatos Ricos was also interested in knowing a little bit about your background, Dimitri, how you got involved in crowdsourcing. Do you come from a systems background, an AI background? And similar, Tick Summers had a similar question about how you started to work with Toloka in this area. And like a little bit about what's your background.
Let's start with the first question. It was all about. Sorry, I've forgotten.
How can they start to work with crowdsourcing?
As a performer or as a requester? So
I think for them it's a requester. As a requester,
you choose any platform you like. For example, Toloka. You just register there. You define your project using the web interface, and you transfer money using the you top up your balance. You just click the annotate button and you receive the responses. That's very quick. As a performer, you do the same thing, but with the performer button. I want to be a performer, and you perform the tasks. So that's usually quite simple. But you need to upload the data. You need to come up with an idea what you want to annotate. But the interface are relatively straightforward. Except you want to do something more complex. So as a good starting point, we offer some presets in Toloka, and you can quickly look at them and come up with an idea what it can be done as a very first step. And is it okay?
Yes, perfect.
Okay.
Perfect.
And the second and the third questions were about myself. Well, usually I don't answer that too often to these questions, but my background is natural language processing. I was a PhD student in Russia, and I was doing lexical semantics studies, computational lexical semantics. So I was designing methods and developing methods that discover senses of the words, meanings of the words. I was discovering the relationships between them, like hypernymy, like other relationships like synonymy, and I was all about trying to build methods that provide language resources for under-resourced languages like Russian, actually. And I came with the problem that, okay, I can design a method, and it might work well, if you just manually look at it, its output, but I needed to objectively evaluate it. And I started to looking for solutions for this problem, and I found that there is some phenomenon called crowdsourcing. It wasn't like back in 2010s, maybe 2012 or like that. I started reading research papers. I was like, wow, there's a mechanical Turk, but from Russia, it's not very available because you need to have some US account to run tasks, and it's not very easy. I found ways to come up with my small crowdsourcing platform that I have written in Java to get some labels from copyright marketplaces. And then I found that there's a crowdsourcing platform by Yandex. It was like in 2015, I think. I said, okay, I want to run tasks on this platform. I was not at Yandex at the time. I was a PhD student still. And they say, okay, no problem. We can provide you with an account. I got the account. I ran this task, and I have become the first external requester of Toloka. And once upon a time, I got my degree. I just ran a lot of crowdsourcing studies. And I found that I like crowdsourcing more than natural language processing. I found it more interesting and more exciting. There is so much undone things that need to be done, so it would be great to join this movement. And then I decided to join Toloka, and right now I'm really happy to be in the front of you and tell the story. Thank you.
Thank you very much, Dimitri. So we also have other questions in the chats and different platforms. I think I'm going to start to reply to them via chat so that we can jump into the practical aspect, if that's okay with you.
Yeah, absolutely.
Okay, thank you. Varias de las preguntas que me parecieron muy buenas, por ejemplo, Sofía Correa hizo unas preguntas excelentes. Me voy a poner yo a respondérselas manualmente en el chat. Y mientras ahorita vamos a tener ya la parte práctica para que ustedes empiecen a trabajar con Toloka, puedan empezar a aprender cómo pueden integrar a estos obreros dentro de su pipeline de inteligencia artificial para que puedan también empezar a participar. Entonces, ahorita vamos a tener a otro investigador de Toloka que se llama Sergi. I hope I pronounced your name correct. Yeah. Thank you, Sergi. Sergi los va a guiar para que puedan ustedes empezar a hacer un demo con Toloka y lo puedan empezar a utilizar. Toloka muy amablemente nos dio becas para ustedes y así ustedes van a poder usar de modo gratuito el día de hoy su plataforma para que puedan empezar a ver cómo es que puedes integrar crowdsourcing en el pipeline para así hacer más eficiente su inteligencia artificial. Y entonces todos ahorita nos vamos a ir a su plataforma de toloka.ai. Gemma, no sé si puedes poner en la pantalla el link. Todos nos vamos a ir ahorita a su página y ahí enviamos por correo información para que pudieran hacer login. Vamos a hacer login y ahí nos vemos. Thank you very much, Sergi, for joining us. We're very excited to have you. And so take it away. Thank you.
All right, gracias. Hola, ¿qué tal? Thanks for staying with us, everyone. I'm Serge. I'm a technical manager and cross solutions architect for Toloka. And now let's develop on some practical aspects of using the platform. Let me just share my presentation. Okay, I hope you all see my screen now, my presentation, and we'll talk about how to efficiently annotate data working with self-driving cars, which is a very hot topic right now. And it's quite an indicative example of using crowdsourcing. So let's start with brainstorming the pipeline, because as Dmitry already told us, one of the most crucial aspects of approaching such a difficult task is a decomposition. So what we need to do is to break down our big task into smaller ones. So now we are working with self-driving cars, and imagine that your task is to help the cars behave properly on real roads. So for a car, everything around it is just noise, and we need to somehow divide the objective reality around the car into relevant pieces. So imagine that we've already collected some very raw data, which is a large set of photos of roads. And now we need to identify particular objects on each photo. So this is our current step. And these are some just examples of raw pictures of some roads. And we need to basically outline the objects on the pictures. So as you see, the objects can vary greatly. It can be people, transport, roads, sidewalks, traffic lights, traffic signs, and so on and so forth. So for your practice session, I encourage you to choose one type of objects because it works. It goes well with our principle of breaking down the task, because there are many pitfalls if you just cram everything you need to annotate into one huge project, because you need to gather your data fast, and you need your process for the performers to be as simple as possible. And if you just ask a performer to annotate all the objects on the photo, it would be such a mess, So we encourage you to decompose such tasks, and by choosing just one type of objects. For example, let's choose traffic signs, okay? And so our formal technical setup is each photo can contain an object of the type we selected, and each picture should be annotated. For example, outlined by a bounding box. And so what this is what we got and what we want to get. Just a raw picture and a picture where all the traffic signs are outlined. So let's come up with a pipeline, because we don't want to jam everything in one project. So again, we have a set of photos. Let's start with a very basic question, whether a photo even contain an object we need, because we have raw data. Don't know everything about every photo, otherwise we wouldn't have used crowdsourcing in the first place, So let's ask a very simple question: does the photo contain an object? Which will basically be our binary classification approach. And now we after such an annotation is done, we choose only those photos that do contain the object in question. And now we send them to our next project, which is we ask our performers to outline such an object with a bounding box. So we save time. We make our projects very simple, because you should always bear in mind that the crowd is often not specialists in your field of study. They are like quite random people with very different backgrounds. So you need to make your task as simple as possible. And why would you even want to pay for annotating the photos that don't even contain the object you need? Hence, such a pipeline. So in the project 2, we get the annotation. But how can we make sure that the annotations were correct? because they could have been very random, because people could have misunderstood your instructions. People could have tried to cheat you and make a very random annotation and selection to just rob you of some money. And our end goal is to get quality data. So that's why we make the third project, where we ask different people who didn't work, who hadn't been working on the project 2, about the quality of the bounding box annotation. And if the annotation was incorrect, we can't work with such a result. So we can even send these photos back for re-annotating. And if the annotation was correct, we can use them in our resulting data set. And a cool feature in this approach that can save you a lot of money, because always bear in mind that while working on real projects, you pay real money for the tasks, and you want to spend it as efficiently as possible. So what I'm talking about is the post-acceptance approach, where you tell your performers that you will only pay for those tasks that were completed correctly. Okay, so this is our whole pipeline, but unfortunately we will have time for implementing only the very first project, but it will be quite useful anyway. So project 1 is about filtering out the photos and asking this crucial question: does the photo contain objects of the desired type? And we will be talking about traffic signs in my presentation. So this is a pretty straightforward binary classification type of task. And now we'll need to think about how to control the quality of our results in this very first step. And as Dmitry told us, there are several crucial points. First of all, we will need to come up with an instruction. I know it will be pretty straightforward in this example, but always bear in mind that instruction is basically the key to success. And after we've explained how to work with our project, we will need to control the quality while it goes on. And here we will use a golden set approach, which is basically a pre-annotated set of data where we already have the answer, the correct answer, and we will compare the answers of our performers with the so-called golden answers, and just calculate the percentage of the real answers that were correct. And another approach that goes well with this golden set control is an overlap, because we really want to tap into the wisdom of the crowd, and we can show the same very task to different performers to collect different opinions. So, for example, if we set overlap 3, it means that the same photo will be shown to 3 different performers, and we will be able to aggregate their answers into one that will be more accurate, than just one answer from one performer. And as for pricing, it would be not so expensive. It's okay to show like a dozen of photos, like 10 photos, and pay 1 cent for them, because this task is very simple and easy to complete. Okay. So I guess we'll save time and stop here, not elaborating on the consecutive projects of our pipeline. And let me remind you that you've all got the links and the information about how to log into Locker, and you've all got your sets of instructions to try it yourself. Hang on, I'll just share another screen. And now let's develop on some technicalities. All right, so what you need to do is go to telako.ai and sign in, as always. Here you have two options to start earning money as a performer or try the platform as a requester. So let's get started. Let's choose our account. Oh God, Jesus Christ. I know. Crowd Solutions Architect Live intensifies. Jesus. Yeah, let's just see what the password was. Hang on. Oh my God. And then let's try this one. What? Hang on a second. I'm very sorry for these technical difficulties. But you can always try it yourself. I hope it's working for you. Oh, you all got that message. I'm so sorry. Let me just stop sharing and trying to solve this problem on the go. I'm very sorry for that. Just give me a second.
Hola a todos. Ahorita les vamos a pasar información para que puedan ustedes acceder a la plataforma de Toloka y tener fondos en su cuenta para que puedan usar la plataforma y empezar a ponerle tareas a los obreros. Ahorita, al parecer, hubo un error con los datos que les enviamos, en donde tenemos acceso restringido y estamos tratando de arreglar ese problema. Pero mientras, voy a hacer, mientras estamos arreglando el problema, una recapitulación. Sergey, while you're fixing the problem, I'll explain in Spanish a little bit about what you explained. And feel free, once you fix it, feel free to...
Much appreciated. Yeah, sure.
Ok, entonces, básicamente, el Dr. Serge lo que les presentó fue el pipeline sobre cómo pueden integrar a obreros para que les ayuden a mejorar sus aplicaciones para coches autónomos. En el caso de coches autónomos, ¿qué se vuelve importante? Que la computadora pueda empezar a detectar, por ejemplo, objetos que se están moviendo en la pantalla y pueda, así, por ejemplo, al poder reconocer los diferentes objetos, tu inteligencia artificial va a poder tomar decisiones de no, pues, o sea, ahorita me tengo que parar porque aquí hay un coche, un tren que está pasando, aquí tengo que dar la vuelta y tengo que tener cuidado con estos peatones que están pasando. Es sumamente importante, dado que está trabajando el coche autónomo en el mundo real, es sumamente importante darle suficientes datos etiquetados sobre cómo está actuando el mundo. Entonces, por ejemplo, tal vez las calles en México son muy diferentes a las calles de Estados Unidos o de Rusia, y entonces es importante que los obreros etiqueten de un modo adecuado todo el contenido de lo que está pasando. Entonces, ahorita Serge lo que nos enseñó fue el pipeline para que a los obreros tú les puedas dar la tarea de que etiqueten imágenes y video. Y el etiquetado involucra primero que digan, no, pues en esta imagen sí hay un objeto que vale la pena que la computadora vea. Y después otra tarea que hacen los obreros es que hagan un círculo sobre en qué parte están saliendo estos objetos. Y ya con ese contenido etiquetado, la computadora empieza a aprender, así es como se ven los peatones en la Ciudad de México cuando son las 6 de la tarde y empieza a estar un poco oscuro. Entonces, eso es básicamente lo que empezamos a ver ahorita con Sergi. Y lo que vamos a hacer ahorita es ya un ejercicio en donde tú también vas a poder darles a obreros a que te ayuden a etiquetar imágenes. Y vamos a empezar. Ahorita nos acaban de compartir la información. Va a ser la misma cuenta que les enviamos y lo único que cambió fue la contraseña. Entonces, ahorita se los ponemos en el chat. Les vamos a poner el password. Y ahorita también se los envío, sino por correo. Básicamente, van a usar la misma cuenta que les enviamos por correo y ahora ese nuevo password. Sergi, I'll pass it on to you. So I just shared the new password. El password se compartió en el chat y ahorita les voy a enviar un correo con la información. I'll give it over to you, Sergi. I'll send out the email so that everyone also gets it.
Thank you, very much appreciated. So once again, for this technical difficulty, you'll be given new account details. Let's see if you can see my screen now. Yes, you do. So this is your main screen after you successfully logged into your requested account. So Dmitry already told us a bit about how we organize this interface and about the crucial entities we use here. So what you want to do is to check your instructions and just go step by step. This is the suggested pipeline that we already discussed. And now let's go through the project creation, adding a pool of tasks, uploading the tasks themselves, our raw data set, and launching it for the performers to work with the tasks. Okay. So again, we organize working with our tasks into three crucial entities. The project, which is basically the interface and how it works with your input data and output result data. It uses several approaches from organizing your project into just one JSON file, or you can use your knowledge of HTML, JavaScript, and CSS to design your project. Then inside this project, we will make pools of tasks, and a pool is needed to organize your data set to apply all the quality control rules, all your overlap settings, and your filters, because you don't want just completely random crowd of people. You want to select only a relevant subset of performers, and here is where your filters come in. And then we have just the tasks themselves, which, as Dmitry told us, is a TSV file, a tab separated value file, which is very useful if you work with pandas and Python and whatnot. So we'll be working with the project, the tasks, the question, does the photo contain? Let's choose again. Let's choose traffic signs, and so we will ask whether the photo contains traffic signs. So this is how you log in. Oh my God, we've logged out. And again. So you log in, make sure that English is set as your interface language, because we have Russian as well. And now let's create our very first project. We have a different selection of templates, so that you don't need to come up with the interface from scratch. And let's see. So yeah, we need to some template for working with images, and let's choose image classification because that's what we need. Just a binary image classification. So we have different tabs in our project settings. The first tab is general information, and in this field to the right, you can see how your project will be visible on the platform for the performers. So let's just name our project, like that's the image contain a traffic sign. Okay, and we need a short description for performers. Select images that contain traffic signs. Okay, with traffic lights or whatnot. Let's save this tab, and this is the gist of our project. This is where we design our interface. So again, we have a pretty neat and quite a new feature that organizes our project as a JSON file, which is called a template builder. But for now, let's work with the HTML, JavaScript, CSS combination. So here we have our HTML field, our JavaScript that we use to set up the logic of how you show different interface elements, how we process data on the go inside our interface, and so on. And CSS is obviously for for some design features. So what we will need to have here is to show our question again. We have traffic lights, and I've chosen traffic signs. It's up to you. If you don't want to be confused, we can go with traffic lights. No problem. Here you can see the eye image, which is a preview button. And that's how our project will be visible to your performers. Here we'll have our image and a question. So let's just rename our radio buttons. The value is what we get in an answer. We'll get a string answer, and the label will be visible for the performers. So again, you can just just copy paste or type in all the necessary information, just like that. Okay. I believe we don't need to touch the JavaScript and CSS settings. Okay, and now let's check the input and output data settings, because again, the project takes in your input raw data set, shows it in the interface like you've designed in the previous step, and gives you the result data after your performer submits the task. So you have different settings, and yeah, our input data is just a URL of an image, which was given to you in our sample data sets, and we get a resultant string with an answer. Okay, just ignore some things in the instruction, like the like checkbox and whatnot. We've just updated our interface and our templates, hence the possible confusion. Okay, so we just save it and write a pretty concise instruction for your performers, like task you'll see photos of the streets, and you need to identify you basically need to Let's see the question whether traffic lights, not to confuse our performers, because there can be more than one traffic lights in one picture. So much stuff. Just yeah, right. This is not an elaborate task whatsoever. Okay. We also have a cool feature with add-in translations, so that you don't need to make a separate project for different language. So here it's possible to add Spanish translation, Portuguese, etc., etc. Just add it, and it applies to your interface. It corresponds to the language chosen for the interface in the performance profile. Okay, so let's make sure that we saved everything. Okay, so now we need to organize our tasks somehow and make a pool. Okay, so we've successfully, I believe, went through the project creation and now pool creation. You just add a pool and start setting it up. So we've agreed upon the price of 1 cent per task suite. If you remember how the project was looking at the preview, that was task suite, just a screen with tasks. There can be only one task on the screen. There can be several tasks on the screen. It's up to you, and usually it depends on the difficulty of one particular micro task. So if it's difficult, you can just put one task on the screen, or if it's as easy as this one, you can put like 10 tasks on the screen, and your performer will need to complete all of them to submit the complete suite of these tasks. Okay, so since we made our interface in English, we don't need performers who don't know the language. You won't be able to read our instructions and descriptions. So here where the filters come in, and you're going to use them to get a relevant subset of your performers. So we have very different filters working with the client applications, because we have Toloka for desktops, for smartphones, and on smartphones they can work via a mobile browser or in a separate application. We can choose different types of operating systems. We can select performance by region in different settings, by country, date of birth. It's very useful for very different kinds of tasks, like, I don't know, for surveys. You can choose different sets of performance for surveys. You can even make spatial tasks where you ask your performer to go somewhere in real life, on location. For example, take a picture of some object, and the region of the performer will be very relevant. So what we want to do is just, for now, select that our performer set English in his profile. It's not the interface language, it's the language that the performer claimed to know. You don't use the non-automatic acceptance that we were talking about. I'll discuss in bounding boxes and how to control the data output. And we agreed upon choosing the overlap of 3. It really goes well with aggregation methods. for example, like majority vote and more advanced ones. And now, I believe our data set has control tasks, and anyway, we can make them ourselves. So let's come up with some quality control rule working with the pre-annotated tasks. So for example, if a performer gave us at least 3 responses, yeah, then the percentage of their correct responses was like less than 60 or 65 for these tasks. Yeah, you will be trying 60. Let me just be on the same page as you are. And then if our performer is basically not better than, you know, a coin toss, I guess it will be better to just ban them. We don't want to ban them for all our projects. We just ban them on this particular project. You can ban them for a number of days, like 10 days in your instruction. You can ban them for hours or just forever, you know. Yeah, just a reminder for you is why we banned your performer. It will be visible only to you. So we apply as well. We can apply different types of control rules, like if they respond too fast, we can ban them, because, you know, they can be cheaters that just click through your tasks very fast. We can set a limit of responses that one user can submit in our project. It often comes in handy, and something like that. Or if we have an option to skip your task, but if a performer skips too many tasks, I guess you don't need him or her. All right, let's see if we filled in all the necessary information. And now we have a pool of tasks, and we just need to upload our data set. Okay. This was quite a useful feature. We could have set up the maximum amount of time that the user can spend on a task, because when your performer takes the tasks, it becomes reserved for them until this amount of time passes. So make sure not to make it a huge amount of too low, this limit of time, because you really want to give your performer some time. But on the other hand, don't give them too much time, because, you know, if your performer just takes the task and forgets about it altogether, this task won't be given to another performer for completion until this limit of time expires. And now let's upload a pool of tasks. So I believe we were given the link to the tasks, to the data set, just a raw data set of pictures. Let's see here. Yeah. Okay, so what you do is just change y, y for just to random number from 1 to 10 or something like that, like 5, and you get your data set. Oh, I've already downloaded it, so yeah. I guess you can't see it now. Let me just share everything I got so that you see how it looks like. Yeah. So this is our data set. It's just a collection of links to our raw images. Okay. Sorry. I'll just change my sharing settings. Yeah. Okay. So now we are on our pool page, and let's upload our tasks. So we have different settings for how you can upload the tasks. Let me just quickly check your instructions to be on the same page as you and know how you will be approaching it. All right, so we've decided upon putting 10 tasks per page, and we use control tasks. So what to do is make sure that each task suite contains 9 main tasks without any prior knowledge about that, and 1 control pre-annotated or golden task, so that each time our performer hands in such a task suite, we know that he or she has given us the answer for which we already know the correct one, so that we can control the quality of their performance. Okay. So we are ready 100 tasks. While we are saving the data set, I believe we don't have any control tasks, okay? But the interface provides an opportunity to make it themselves. For smaller data sets, we would need around 10% of our tasks to be the golden ones, to ensure the best quality. Okay, sorry. Let's quickly check the chat. All right, so let's create control tasks from our raw data set. Let's see, yeah, we're working with, again, the traffic lights, not traffic signs. Okay, I can't see any traffic lights in the picture. So what you need to do is choose the output field that will control the answer and provide the answer yourself. So this picture, I mean, doesn't even contain a traffic light. Okay. Next one. No. It's the second one. Let's find a picture where there are indeed some traffic lights. So here there is an interesting question: what should be the distribution of your objects? Because you might want to keep the same distribution in your control tasks like you have in your real data set. But if you have a skewed data set, you might stumble upon some difficulties. This way, it applies for your training set, because for harder tasks you can make a separate pool with only training tasks where you provide the correct answer and even explain why this answer was correct. So you want to show each type of possible answers, each type of tricky situations for your performers. So I usually try not to make a skewed, distribution of golden sets. That's why I try to find another. Did I save it? Yeah. Okay. Okay. Now you see the distribution here. Yes, this picture always also contains a traffic light. And this one, green one here. And this one too. And this one does not. Nice. You have 6 control tasks. For more to go, no. I know it's quite a chore. So for longer pipelines, you can even try to collect the golden answers from your performers as well. So like you can get good answers from your performers without golden sets and then reuse them as the golden ones in your consecutive projects. This is also a legit approach. Yeah, we have traffic lights here. Okay, and the last one, yeah, we have. Okay, so let's see how our pool looks now. Oh, we have 12. It's all right. So now we have our control tasks and main tasks. We have our overlap set up. So make sure that we have all the filters. And now we can basically start the pool. Because, yeah, this notification just tells us that we didn't set our filter to show our project for mobile devices. But since we're working with pictures, with small details, I reckon that it's better to keep it just for the desktop users. All right, so let's just launch the pool. And you see that right now, this second, around 9,000 people are ready to take our task. Let's see if it's true, and let's actually see if anyone else tried to. Oh my God, I love you. That's so cool. So several people have tried to make their own projects themselves. Awesome. Don't forget to rename your project if you don't want to learn the cat's mood. But if you have such a data set, just feel free to go. And while we are waiting for our pool of tasks to be completed, I guess that I can answer a few questions if you want me to.
Hi, thank you, Sergi, for the great explanation. So I'll help you to respond to some of the questions. So we were receiving, from what I saw, and you can also see some of the questions in the comments, and we also have them from Ria's chat. So I think that some people had questions around, they didn't understand very well the pools. And from what I saw, that there were some people that were struggling if they needed to code anything when they were getting ready for the pools. I don't know if you want to respond to that question.
Yeah, I could. Yeah, sure. So as for coding, you can either try to to omit coding altogether by choosing a proper template, or you can just learn some very basic stuff about HTML. It'll help you a lot. Or you can try using our template builder, and for that we have our guide, our manual, and template builder was made to solve the problem of using HTML. So we know about this, about rather high threshold, of entering this world of designing projects. So you can try our template builder. And as for the pools, we use this entity again to organize our tasks somehow. So we have a project that takes your input data and gives you a black box, not so black if you know HTML and JavaScript, but anyway, a box where your data is processed and gives you output data. But then you have just a raw CSV file, and you really want to apply some filters, some control rules, some settings. So the pool is just an entity for your convenience to somehow organize your tasks. Because, for example, if you have the same project and different data sets, for example, for different types of people, you have a data set for Spanish-speaking audience, for English-speaking audience, or like for young people, for senior people, you can make separate pools with different settings. So your project interface will always stay the same, but within this project, you will have different samples, different data sets, So that's why we use such an entity as a pool.
Actually, thank you. That makes a lot of sense. I wonder if you guys could share. You mentioned that you have tutorials where they can read more about, for instance, the possible templates that they can use, etc. Where do you recommend that they should read more? Because we had some questions related to like the pools, and I think especially that template builder. Some people had for the task for the pool. Your CSV file that you had, I think some people had questions there, and so maybe giving them material so that they can read more could help them.
I see. So yeah, my colleagues will provide with all the links. And now I believe you can see my presentation, and let's go to the very end of it. And
great presentation. Great presentation. Thank you.
So yeah, we have our community on Slack, where we discuss everything crowdsourcing. You'll also be given links to our tutorials on the platform. Tlock.ai also has a great knowledge base, some of best practices, approaches, articles and such. We have actually very proud to have our online course on Coursera, a very popular platform for online education, and we have a complete course there to learn about crowdsourcing in general, not only about Tlock, but all these approaches like Dima was discussing, and also they have a practical course that explains all the advanced techniques of using the Tlock platform itself. So yeah, I hope my colleagues will give all the links about it.
Thank you very much. Thank you very much. That's great about the promo code. Les acaban de dar un promo code para que puedan hacer sus propios proyectos y explorar la plataforma. I think that's going to be great for them to get some practice. And I think actually those were, I think that where a lot of people said, as you mentioned, that they were able to complete the tasks that you set off. And so it seems that the main questions were around the pool and what it meant. And we just shared the link that you shared about the knowledge base. Somebody is asking, on Amazon Mechanical Turk, I sometimes give workers code to complete surveys that are outside Amazon Mechanical Turk. Here, I do not see that functionality.
We encourage our performers to, we encourage our requesters to make our performers stay inside the platform because it's easy to organize. But sometimes our requesters do provide external links, and it's a legit approach. And yeah, we have cases where exactly people, go to some external survey and then enter the code inside our platform. That's all right. There is such a functionality. It's just it's not an built-in template, but you can come up with it pretty easily yourself. You just make a text box where the code should be entered and such. So yeah, it's a legit practice on our platform as well.
Wonderful, wonderful. I think those were the main ones. I don't know if others want to comment. And right now, Alina and Sergey shared the promo code. Thank you very much to Luca for that promo code. I think that's going to be great for the students to start to get some practice on Toloka and start to use Toloka. Oh, yeah, we had, from what I'm seeing is that we had similar questions related. Right now I'm looking through the comments. I think that where a lot of people had questions was in the pool. But you guys shared right now really good material. So thank you. And thank you, everyone. It looks like actually, surprisingly, we were able to finish on time. We went through a whole lot of material and we finished on time. Really nice job, everyone. Thank you so much for joining us. And thank you very much to Luca for this great course. And thank you also Tecnolatinas for this awesome collaboration. UNAM and Infotech and Ria, of course. Thank you, everyone.
Thank you.